Okay, today we're going to wrap up section 4.2. All right, we're going to do a little bit more with evaluating these trig functions using the unit circle. We didn't tackle quadrantal angles yet, so we're going to do that right away. And then I'll show you how we just use domain and period of these trig functions to evaluate any of the trig functions, really. Okay, we don't really need to spend much time with the calculator. Learning target for now. Okay, so quadrantal angles were not addressed yet. Let's go ahead and write this down. They're right at the top. Let's define this. So quadrantal, so you start by just spelling the word quadrant and then put AL, okay? Pronounce quadrantal. What's a quadrantal angle? 90 degrees is an example of a quadrantal angle. Any angle that kind of terminal side falls in between quadrants, I can't name 90 degrees. It's not between one, it's not in one or two, it's between one and two. So quadrantal angles are angles that fall in between quadrants. So angles that lie or rest or terminate, I would say terminate between quadrants. So angles that terminate between quadrants. Okay, so any multiple of 90 degrees or pi over 2 is what they're talking about. Another way to, you can even add it here if you want, it means its terminal side lands on an axis of some sort. Okay, 0, the angle 0 is a quadrantal. Pi over 2, pi is. Okay, there's a bunch of them if you just keep rotating, right? Okay, so number 6 is a quadrantal angle. So let's go ahead and take a look at 6. The math works out really easy for these quadrantal angles. So it says angle is pi over 2, and we're going to find all 6 trig functions still. So what coordinates will we be using? So pi over 2 starts here, rotates, and the ending spot will be right here. So we're going to use the coordinates 0, 1. Maybe we should even make note of that here. So using 0, 1 for our coordinate. Okay, and then of course we still have a radius of 1. So I've got x is 0, y is 1, r is 1, and this gets work. So sine of angle t, or you could even write sine of pi over 2 if you want. It's up to you. Because remember, the sign changes depending on the angle. All right, so sine of pi over 2 is y over r. So I'm looking at this. I'll put the definition here once, and then we'll just kind of continue. 1 over 1, so it's 1. Okay, cosine of angle t, or pi over 2, is x over r. So we have 0 over 1. Okay, let's go ahead and do the reciprocals as well. So 0 over 1 reduces to 0. So the cosecant, it's r over y by definition, but all we got to do is take the reciprocal of 1 and we get 1. Secant of angle t, so I got to take 0 over 1 and flip that over. That's 1 over 0. We can't divide something by 0, so what we say is it's undefined. You can just do UND if you want, period, to abbreviate that, but this is undefined for secant. That's going to happen sometimes. That's why we actually wrote that down on the previous page yesterday, that sometimes it might not be defined when x is 0. And that's what happened. Okay. All right, and 2 more. Tangent of angle t is defined as y over x, so 1 over 0, which is undefined as well. Okay, so yeah, you can't really take a reciprocal of undefined, so you just go back a step and flip over the definition. Instead of y over x, cotangent is x over y. So I wouldn't say this one's undefined as well, because we'll have 0 over 1, which is 0. Okay, so that's a quadrantal angle. Any of the quadrantal angles, if you notice up here, they involve zeros and 1s, right? 0, -1. This is -1, 0. Okay, so similar math, but obviously the coordinates will change a little bit. Okay, go ahead and pause the video and you guys try -2 pi. Okay, here's your feedback on 7. I'll try to put the definitions here too. We're using 0.10 because negative 2 pi rotates a full revolution and ends where it started. So those are our coordinates, 1, 0. And here is the solutions. Okay, let's go ahead and turn the page. Okay, let's get into these periodic properties. Basically, when functions are coterminal and share the same side, you'll have a similar ordered pair that you're going to use. Okay, I'll demonstrate here in just a moment. I want you to write this down first. Domain is all real numbers for sine and cosine. They don't have any restrictions. Any angle, we will have an answer. We won't get undefined for sine and cosine at all. Okay, so the input values are all real numbers, all angles, even if it's greater than 360, 400, 500, 1000, all input values work. Okay, so here's the idea of the periodic nature of these. Functions that behave in a repetitive or cyclic manner. Functions that behave in a repetitive or cyclic manner. So the period is 2 pi, or in degrees is 360 degrees for sine and cosine. So essentially what that means, just give you a quick little example, is that if we were to find the sine of 30 degrees, it ends up being the same as the sine of 360 plus that, which is 390 degrees, because they're coterminal. Phrase we used in 4.1. These are equal. Let me show you why. If we look at this unit circle, 30 degrees rotates right here. Okay, so there's 30 degrees. 390 would rotate all the way around to 360, and then here's an additional 30 degrees. Okay, so they both fall at the same spot, use the same coordinates. They would have the exact same answer when we do y over r. So that's the idea of the periodic nature. They start to repeat themselves for every 360 degrees or 2 pi. Okay? All right, so we don't have to get too fancy with the notation of this. We're basically just, if you draw the angle, then we'll be able to figure it out. Okay? Okay, we're going to skip the even odd trig functions too. We'll use these in chapter 5, but right now we don't really need it because if we draw the angle correctly, all these even odd identities take care of themselves. Okay? All right, so let's take a look at this next example. Okay, so to evaluate this trig function, they're just asking for 1. They're not asking for 3 or 6. Cosine of 4 pi. Let's start by drawing the angle. Okay, cosine of 4 pi. That angle, we're going to start here with our initial side. 2 pi rotates to there. And then how much more do I have? I still have another 2 pi left over. Okay, so there's an angle of 4 pi. Okay, just like you did negative 2 pi and it landed at the same spot. They're coterminal. All right, so then we can go to that. Unit circle on the previous page and figure out what coordinate that is. I mean, it's kind of obvious. If we got this circle here and the radius is 1, it's just 1 unit over. So this coordinate is 1, 0. But if that's not obvious to you, then we would peek right here, right? Okay, so now I have x. Now I have y. So cosine of 4 pi radians is equal to x over r, so we get 1. And that's it. Okay? So that's the idea of the periodic nature. Cosine of 4 pi is the same as 2 pi, same as 6 pi, 8 pi. Anytime it lands there, we're going to get the same answer. Okay? All right, let's take a look at 9. 17 pi over 6. All right, so let's figure out this angle first. This is 2 and 5/6. And that might be enough using that the unit circle that we have. But here's a little sketch of this. Or this is 510 degrees. If you want to convert it and use your 5-1 skills, you could do that. All right, so 2 pi rotates around like this. And then what do I have left over? 5/6 more. So 5/6 more pi is going to be, 5/6 of a straight angle somewhere around here. And it's labeled again on our unit circle right here as 5/6 pi. So those are the coordinates I need. And I'm going to write that down on the next page now. Okay, so using, let's see, I think it was negative square root 3 over 2, and I think it was 1/2. Yep, positive 1/2. So we're going to use that coordinate to figure out what sine 17 pi over 6 is. Okay, so it's equal to y over r. This is my y value divided by 1, so my answer is 1/2. Okay, let's have you try this. 10 isn't actually really periodic, but whatever. Let's give it a try. Let's just try 10 to wrap this up. Okay, so negative 5 pi over 4 rotates and splits quadrant 2 right in half. So when you find the coordinate that fits, it's this one right here. Okay, so cosine by definition uses our x value. So x divided by a radius of 1. So the answer is negative square root of 2 over 2. Okay. All right, the last page of the notes we're actually going to skip for now. The main focus here in section 4.2 is this introduction to the unit circle and what that means. Finding the right coordinates. Okay, and also memorizing all these definitions that we went over the first day. Having these down. I'm not going to give you these definitions in the reciprocal relationships. All right, through 4.2, we're learning that and we're memorizing these relationships. Okay? All right, that's it.